Hello, welcome back to Battle 24. This should be page 40. Yeah, page 40 is still Battle 24. This is section 3.4 is the chain rule. This is the chain rule. The chain rule, I think, is one of the most powerful differentiation rule or technique we can use. One of the most powerful differentiation rule or technique. And how we define the chain rule? If we define a function as f inside of a function gx inside of fx, and find f prime of x, then we need to let the chain rule that u equals to g of x, and we compute fu, we compute f prime of u, and we treat gx as inside function. And f of x is an outside function. So for chain rule, we just take the derivative for two functions. We differentiate the inside function and the outside function. So if f of x is equal to f gx, then f prime of x is f prime of gx times g prime of x. We differentiate two functions. We all need to be calculated. Let's do an example here. Compute f prime of x if f of x equals to sine of 10x. tan x squared. First mistake you need to avoid. I prime of x is not equal to cosine tan x to the squared. No, never ever. Or if you know this is gonna be, or if you're gonna do this, also no. What we need to do is we need to let inside function is a tan x to the square. We need to let u equals to 10x to the square. Du is 20x. Then f prime of x is d du sine of u times d dx 10x to the squared, and we get cosine of u times 20x. We substitute the u back here, and we have cosine to the 10x to the squared times 20x is our final answer. Another example. I think this part of the thing just more computational because it's to find the derivative of a lot of functions. Do another example 2. Find g prime of x if g of x is equal to cosine of 2x times ln x squared minus 1 minus tangent of x plus 1. Maybe just pause the video, then try yourself on and try it on your own, see if you can do this problem. And what rule we do, and we basically need to use all of the rules because we need to add product rule, sum rule, difference rule, chain rule, but quotient rule. So g prime of x is equals to cosine of 2x ddx is natural log of x squared minus 1 plus natural log x squared minus 1 ddx cosine of 2x minus ddx tangent of x plus 1. We do it 1, 2, and 3 here. Was this a fly? I apologize for the pause. We do this. Equals to cosine of 2x ddx is natural log of x squared minus 1. U equals to x squared minus 1. du is 2x equals to cosine of 2x times d du is natural log of u times ddx x squared minus 1. Cosine of 2x minus 1 over u times 2x. So we obtained cosine of 2x times 2x over x squared minus 1. This is our step 1. The equation 1, we get this. And number 2, another product rule is natural log of x squared minus 1 ddx cosine of 2x u equals to 2x du equals to 2. Then we get for natural log of x squared minus 1 ddu cosine of u ddx of 2x. We have is natural log of x squared minus 1 times is like a negative sine of u 2. And we have is negative 2 and natural log of x squared minus 1 times 2 sine of 2x. This is what we have. And the third one, it is easy. Now I do the algebra here, so and we can get it just the ddu tangent of u ddx x plus 1 equal to secant of a square root of u times 1, and we have is secant of x plus 1 to the squared is this. Because like the derivative of x plus 1 is 1. So g prime of x is 1 plus 2, 1 plus 3. So we get is minus 2 natural log of squared minus 1 sine of 2x minus secant squared of x at 1 is our final answer. This is a hard one. I hate this technique, but it's useful. (42). Let's try another example here. Okay, so far we count 2 plus 1. The third example here. Find h prime of x if h of x is equal to x minus 4 and e to the x squared minus 1. Quotient rule here. Quotient rule. We need to use the quotient rule. Maybe pause the video and just try to do everything wrong. Just to try to do everything wrong. So, and back to it. Next, ex squared minus 1 minus ex squared minus 1 ddx of x minus 4 and the bottom is x minus 4 to the square, so we write as this. Then we can do this ddx of ex squared minus 1 equals to d du e of u ddx x squared and minus 1 u equals to x squared minus 1 du equals to 2x. We get is u times 2x. The final answer is ex squared minus 1 times 2x. So h prime of x is 2x ex squared minus 1 times x minus 4 minus ex squared minus 1, because this is the derivative of x minus 4 is 1. And the bottom we get x squared minus 8x plus 16. This is our final answer. Any questions here? And we proceed to the next example here. Gonna be applied problem. Find the slope of the tangent line to the curve x squared plus 16 at x equals to 3. So as we recall, for the slope of a tangent line is the derivative. So let's compute this. We might use the chain rule. Might use the chain rule this time. So let's compute. Let's compute f prime of x first. Being that u equals to this. U equals to x squared plus 16. Then du is 2x. du like the square root of u into ddx x squared plus 16. This is a u to the 1/2. Remember this. Okay, 2x. We have is 2x over 2 x squared plus 16 is function of f of x at prime of x. And what we need is f prime at x equals 3. So we equal to 2 times 3 or 2 squared plus 16. And we get is 6 over 2 times 25 squared 5 is 10. It is 3 over 5 is our final answer what we need. Page 43 should be. The 43 is find f prime of x if f of x is equals to 5 over e power to the 2x minus sine of 2x over cosine of 2x plus natural log x plus 2. Maybe pause the video, try to do it on your own. Perhaps this is on the midterm. We can rewrite the function as This is yield. That's this. Then compute the derivative. We just do the algebra, so here we can do it as the negative 10 e to the negative 2x minus secant squared of 2x times 2 plus this like natural log x plus equals 1. And we get the final answer, it is f prime of x equals to negative 10 e to the power of negative 2x minus 2 secant squared of 2x plus 1 over x at 2 is our final answer what we need. Okay, now let's do another example here. Example number 5 is this should be find the equation of the tangent line to f of x equals to e2x cosine of 4x at x equals to 1. Two technique, the product rule and the chain rule. This is what we need to do. And we need f prime of x to e to the 2x ddx cosine of 4x plus cosine of 4x ddx to the e to the 2x. And we have is negative 4 sine 4x e2x plus 2e2x cosine of 4x. This is the tangent line. Actually, this is derivative. We need to find, we also need f prime of 1 is equal to negative 4 sine of 4 e squared plus 2 e to the 2 cosine of 4. We just take a kind of like an approximation. So here's a calculator. plus 2 e to the square cosine 4, 12.68. So the equation is F1, that is, we need F1, we do a quick computation, that is e to the squared times cosine 4, 7.37. And we have as that's it. Page 44. Now I'm going to do one example here. Let's do a quick summary. One, if a function looks like f g of x, then let u equals to gx. Compute f prime of u times g prime of x. So if a function is like this, let u equals to x plus 1 compute two functions. It's possible to use the chain rule multiple times. So let's do an actual example here. Find g prime of x if gx is equal to is equal to natural log of sine of cosine of x. Then we need, then first we took first, we take lecture log of and this inside function. We need to let u, this case equals to sine of cosine of x and see another email came out here. We need to do like the u substitution as here once. And you also need to do another substitution as cosine of x. And the final answer is, here's the final answer. I remain mystery. I will try see this as an exercise, and I will post the answer for this question in the video for section 3.5, which will deal with implicit differentiation. Thank you guys all the videos before the first midterm. And next video I will do a review for first midterm. Okay, I will review the answer for this in next video, not section 3.5. Thank you so much.